A very good evening to all of you. My name is Deepak Arora. Today we are going to discuss the third session of strength of material. So if you remember yesterday's session and the day before yesterday's sessions, we have discussed the concept of simple stress and strain, and today we are going ahead with the next chapter, that the shear force diagram and the bending moment diagram. So if you have any doubt or any query related to the yesterday class or day before yesterday's class, you can ask in the chat box. Definitely I will answer your query. Okay. So shear force diagram and bending moment diagram is one of the easiest chapter in a strength of material, and you will feel like that's a free marks in the exam. Okay, if the question will come from this topic, so it will be free marks. It's not a lengthy question. First, whatever questions are coming from these topics are not at all lengthy. Okay, you may just give the answer in 2 or 3 lines maximum, or just by seeing the question you will get the answer of this chapter. Okay, so in the next starting 15 to 20 minutes we will discuss about what is the concept of shear force diagram and the bending moment diagram. Then we will solve the number of problems on this topic. Okay, before that, if you have any doubt of related to the simple stress and strain, you can ask me. So in simple stress and strain, we have discussed about the stress and strain, true stress, true strain, unloading of the material, and we discussed about the axial deformation, deflection due to self weight, and the thermal stresses and the statically indeterminate problems. Okay, so 5 to 6 things which are important for the exam we have discussed in the last 2 classes, and for the mechanical, it's very much sure the question is going to come from the topic which we have discussed in the last 2 class. Okay, that's a very important chapter for the mechanical engineering. 100% the questions are coming in all the years exam from the first chapter. Okay, shear force diagram, bending moment diagram is very much important for the civil engineering point of view, because it helps us to understanding the concept of slope and deflection. Mayank, I will not spend much time on this, but maybe you doesn't need, maybe other students need this topic. Okay, so I will not go in much detail, but I will just give the basic idea. Then we'll move to the stresses in beams chapter. Okay, I will not go in much detail, but maybe the someone is required, because the question is very easy from this chapter. Okay, so maybe your concept will also improve of this topic. Okay, so if anyone any doubt, you can ask me related to the yesterday's class or day before yesterday class, or I will go ahead with the today's topic, that is SFD and BMD. Okay, shear force diagram and bending moment diagram. Okay, SFD and BMD. Okay, the first question generally comes in the mind, especially for a civil engineering. You guys draw the SFD BMD throughout the civil engineering. Okay, so many subjects you study, in that you draw the SFD BMD or you play with the SFD BMD, you will see the role of SFD BMD. So why do we draw the shear force diagram and bending moment diagram? The logic is very simple. It helps us to design the concrete member. In the RCC beams and all, you will provide the reinforcement, shear reinforcement also, the main reinforcement also. All the reinforcement will be designed based on the shear force diagram and the bending moment diagram. Wherever the bending moment is more, you provide the more reinforcement. Where the bending moment is less, you will provide the less reinforcement. I hope so you have seen the industrial warehouse. There also you will see we are using the tapered section. Okay, why we use the tapered section? The logic is same. Wherever the bending moment is maximum, we provide the more section. Where the bending moment is less, we provide the less section. Okay, so SFD BMD, first thing here is, I hope so all of you are aware, I am not going into the detail of this, but first one is reactions and support reaction. If I say reaction or support reactions, so all of you know the supports, roller supports are there, hinge support is there, and fixed support is there. All of you are aware, roller support is there, hinge or pin support is there, and fixed support is there. Okay, these are my external supports. These are my external support. In a roller support, one reaction come which will be vertical. In hinge support, 2 reaction come, one vertical, one horizontal. And the fixed support, 3 reactions come, vertical, horizontal, and the moment reaction. All of you are aware about this thing, right? But my point is here, where the student get confused, the supports are internal supports. Okay, in the internal support, the student get confused. So what are the internal supports? First one is internal hinge. First one is internal hinge. Okay, so like if I have any beam like that, okay, and this is the internal hinge. Internal hinge means it's like a ring. Okay, two parts of the beam are connected with one ring. So the role is very simple of this hinge. Most of the time if you see the hinge, you get afraid from the question. Hinge is the logic is just break the beam at the hinge. Okay, just break the beam at the hinge and see how it's behaving. If hinge property is, internal hinge property is, the bending moment will be 0 here. Okay, the bending moment will be 0 here. So if I break this beam at the hinge, you will see one part is here and other part is here. Okay, I remove the hinge. Two reactions come here, one is vertical reaction and one is horizontal reaction, and bending moment is 0 here. So one is vertical reaction RV and second one is horizontal reaction RH. So now the doubt comes in the exam, or now the doubt comes in the student's mind, sir, why are you taking the RV upward? I am not saying anything here. You want to take RV downward, you take downward, whatever you want you take. But one thing is very clear, wherever the internal hinge is present, you have to apply the two reactions. One is vertical, one is horizontal. If vertical is like that, on this beam, definitely on this one, it will be downward. And here it's a left to right, here it will be right to left. Okay, now if you want to apply here downward, definitely here it will be upward. Okay, so it's completely your choice. Whatever sign convention you want to take, you can take. It's completely your choice. Okay, it's completely, you are fully free कि what sign convention you have to take. You have to take RV upward, left side, or RV downward. Our mathematics will take care in the last. Okay, so don't. Internal hinge logic is very simple. Just break the hinge and apply the two reactions, vertical and horizontal. Okay, and horizontal reaction, you know, most of the times in the question the load will be only verticals, so horizontal reaction will also vanish. There will be no role of horizontal reaction, only the vertical reaction will be helpful for us for solving all the problems. So internal hinge. One more is there, that is internal roller. I am teaching out these support because I will use these supports in the slope and deflection chapter. It will be helpful for understanding the concept of slope and deflection. So here only I am covering these two supports, which will be more helpful in a slope and deflection also. Internal roller means if two beams are connected like that. Okay, two beams, let us suppose connected like that. There is a one roller in between that. Okay, so what is the property of this roller? Again, I am breaking the beam like that. So when you remove this roller, the one reaction will come, that will be the vertical reaction. Here I am saying RV upward, here I am saying RV downward. Now again you can ask me, sir, why are you making RV here upward? You can make RV downward here, not a problem. It's completely your choice. Whatever you want you can make. In the last, our mathematics will take care about everything here. Okay, so internal roller, internal hinge, that's the important support for the mechanical engineering. Also in the mechanical engineering, if you see the last 2 or 3 years, the questions are coming in which internal hinge is present. Okay, if you see the mechanical engineering last 2 or 3 year question paper, in that internal hinge is present. So question is coming from that. Today we will see the questions also. Okay, so this is the internal hinge concept, right? Next, this must be clear to you. Support reactions must be clear to you. And one more thing, in strength of material, we discussed about only the statically determinate beams. What is statically determinate beam? If number of reactions can be found with the help of number of equilibrium equations which you have in a two-dimensional sigma fx0, sigma fy0, sigma mz0. Okay, these three equations you have. If you have number of reactions more than 3, then definitely your structure will be, and you have 3 reactions and 3 equations. But let us suppose internal hinge is present, you will get the extra equation from the internal hinge also. Okay, so in the last, if statically indeterminacy is 0, then that's a part of strength of material. If it's not, definitely this will be the part of the structure analysis. Now you can ask me, sir, we discussed about the statically indeterminate also in slope and deflection. Yeah, we discussed about the propped cantilever beam only, but we doesn't go in more detail of statically indeterminate structures in a strength of material. Okay, maximum we discuss about the propped cantilever beam that we solve. Okay, all right. Next come to now what is shear force and bending moment? What is shear force and bending moment? I am saying shear force just our word, it's a force only. Similarly, bending moment is just our word, but it's a moment only. But only the difference is when you are adding the word shear and bending in the front of force and moment, this is becoming the internal reactions. Okay, this is becoming internal resistance. Shear force and bending moment both are internal resistance. Okay, force and moment are external. Once you added the word shear and bending in the front of them, it becoming the internal quantity. So that's the only difference. Rest, if you see mathematics, how to calculate bending moment, everything is same as a moment calculation. Shear force also, it's like a, what is shear force? What is shear force? Shear force is algebraic sum of vertical transverse forces either left or right to the section. Okay, means you have to cut one section. If somebody asks you to calculate the shear force at particular section, so it's not like that you can see only on left side or only on right side. You can see either left or right, but it depends upon the question which side is comfortable for you to seeing the shear force. Okay, but the definition is saying you can see either left or right. It's completely your choice. You are free for that. Similarly, for I write the bending moment definition, it is algebraic sum of moments either left or right to the section. Same thing, calculation is same, like you calculate the moment force into perpendicular distance between line of action of force and the point considered. Same thing, bending moment will be calculated, but you have to see which section they are asking to be bending moment. So you have to see either left or right. You cannot see on a complete beam. You have to see either on left, either on right. You have to see. Okay. So this is the basic definition of shear force and bending moment. Now what is shear force diagram and bending moment diagram? A diagram which represents the variation of shear force along the length, that is shear force diagram. A diagram which represents the variation of bending moment along the length, that is bending moment diagram. So no need to worry, SFD and BMD. Okay, it's the variation of shear force, that's the variation of bending moment, that is shear force diagram and the bending moment diagram. Okay, and definition is very simple, no need to worry what the definition also. Okay, third thing is sign convention of shear force diagram and bending moment diagram. Sign convention, I always says sign convention is for us. Okay, whatever comfortable sign convention is there, we can consider. It's not like a fixed rule ki you have to consider this sign convention only. But in the exam, either the gate will mention about the sign convention, ki what sign convention they want you to follow. If they are not mentioning, so I will suggest you to follow this. This is the standard sign convention. Most of the book you will see that they are following this sign convention only. Okay. So what is sign convention for shear force? If this is my any beam, let us say I cut a one section here. Okay. So this side shear force is positive, meaning if you are seeing left side upward is positive, right side downward is positive. It's up to you. Second is left side downward, right side upward. This is negative. Okay, so this is completely your choice, but we will follow this sign convention because most of the books also follow the same. Maybe in the college time also you have also followed the same sign convention. Okay, so we will not confuse with the sign conventions. This is the sign convention, but what is the representation here? I have one section XX here. So if I am seeing left side of the section, upward is positive, downward is negative. If I'm saying right side, so downward is positive, upward is negative. Sometimes what happened, we confuse with force sign reaction sign convention and the shear force sign convention. It means what? We always say, we assume that upward is positive, downward is negative. Generally we consider this sign convention like our coordinate axes are there, plus y upward, down, minus y downward. Okay, so we get confused sometimes. So don't mix the sign convention of shear force with the reactions. Okay, reaction sign convention is completely different, shear force sign convention is completely different. Okay, so don't be confused with that. Next is bending moment. Next is bending moment. In a bending moment sign convention, we assume that this is called as sagging. Sagging is positive. Okay, we consider that sagging is positive, and hogging is negative. Meaning is what? Again, I have one section. If I am seeing left side of the section, left side you can see clockwise is positive and anti-clockwise is negative. But if you go to the right side, you can see in the right side anti-clockwise is positive and clockwise is negative. So again I am saying, don't confuse with the sign convention, because you assume the moment sign convention like clockwise movement positive, anti-clockwise movement negative. So don't confuse with that sign convention, beta. Okay, that's a blunder mistake possible. We get confused with clockwise movement is positive, anti-clockwise is negative. That's the sign convention for moment. This is my bending moment. In the bending moment, you always have to consider sagging positive and hogging negative. Okay, sagging positive, hogging negative, you always have to consider, right? Next is relationship between shear force, bending moment and rate of loading. This is very, very important. Okay, the relationship between them is very, very important. Why it's very, very important? It helps us to draw the opposite also. Opposite means if SFD or BMD is given to us, if somebody asks you to draw the loading diagram for that, so that relationship helps us a lot in these things. Okay, so these relationships are very important. Maximum questions in which the exam will ask you only to draw the shape of SFD BMD. The question will be over using these relationships only. Okay, so these relationships are very, very important. What are the relationship here? The first relationship is dV by dx is equals to W. What is V here? V is our shear force, W is our rate of loading or loading intensity. Okay, V is here shear force and W is here loading intensity or rate of loading. Next we have dm by dx is equals to V. That is the relationship between bending moment and the shear force. What is M here? M is here bending moment. M is here bending moment. So what if you see very carefully this relationship dV by dx? What is that? You are doing the first differentiative, first derivative of shear force. So first derivative of shear force representing the rate of loading. First derivative of bending moment is representing the shear force. Okay, the question have come many times for using this relationship only. In the books, maybe sometime you will find it's a minus W they have written. Okay, in the books maybe you will find they have written dV by dx is minus W. Minus representation is only the loading is downward. Okay, here if you are getting the W is negative, then definitely loading is downward. If you are getting the W is positive, it means loading is upward. So no need to confuse why I have not written the minus here. Minus meaning is only the loading is upward or loading is downward. Okay, so dV by dx is equals to W and dm by dx is equals to V. This is the relationship between shear force and bending moment and rate of loading. Again I am saying maximum question in which they will ask you to draw the shear force and bending moment will be over by these only. Okay. Next is one note. What is that note? That note will complete our whole chapter. What is the note? Note is, let us say this is my loading, this is my shear force, and this is my bending moment. Basically, if you see, we deal with three types of loads. One is the point load, second one is UDL, third one is UVL. UVL questions are also very rare in the GATE exam. If you see, the questions related to UVL are also very rare. The maximum questions are coming either related to the point loads or UDL. Okay, so we have three types of loading: point load and UDL and UVL. Okay, point load, UDL, UVL. Okay, so point load, UDL, UVL. I hope so all of you know a simply supported beam subjected to point load, how the shear force diagrams come. Shear force diagrams come constant type. Okay, shear force diagram you will see it's a constant, or you may say it's a rectangular. Okay, and bending moment diagram will come how? It will be a 1 degree and it will be a triangle. It will be a 1 degree or it will be a triangle. Okay. Similarly, our UDL is called as 0 degree loading. UDL is called as 0 degree loading. So shear force diagram will be here 1 degree. It means it will be again linear. Okay, here you can say also linear also, and bending moment diagram will be 2 degree. It means it will be parabolic. If UVL is present, UVL is called as 1 degree loading. So our shear force diagram will be 2 degree, means it will be parabolic, and it will be 3 degree, it will be cubic parabola. It will be cubic parabola. Okay, so you can see one thing here. It's like that. Okay, so complete table you can remember in this way. This table will complete your whole chapter. If you understood this table will complete whole chapter. If UDL is present, shear force diagram will be 1 degree linear. Okay, 1 degree linear means it will be like a triangle. It will be like a triangle. Second degree parabola, you know. If UVL is present, it will be parabola. Parabola means second degree means parabola means it's a square parabola. And 3 degree means it's a cubic parabola. Only in the exam problems come to which parabola, because if I draw parabola, I want to draw parabola here in the between these 2 points. The parabola possible is like this also, and parabola possible is like this also. Okay, so most of the time what happened in the exam, we get confused which parabola we have to see. Okay, which parabola we have to see. In that deciding the parabola, these relationship will help you a lot which parabola we have to use. Okay, what we have to do, let us suppose you have to draw the shear force diagram. In that parabola is present. So just see where you are drawing the shear force diagram. At that point, what is the W? If W is 0, it means shear force slope will be 0. If W value exists, it means slope of shear force diagram will be also exist. So you have to decide in such way so that slope will be 0 or not 0. Based on this concept only, you can decide which parabola you have to use, either up this one or this one. Okay, so this relationship will help you a lot while deciding the parabola. Second thing, if you see here, if loading degree is n, shear force diagram is n plus 1, bending moment diagram is n plus 2. Okay, if loading degree is, if degree of loading is n, so shear force diagram will be n plus 1 degree and bending moment diagram will be n plus 2 degree. Now you will ask me, sir, these relationships are valid every time? you can ask me, these relationships are valid every time. This relationship is not valid for one case, that is the except. I am writing except. Anyone can tell me where this relationship will not be valid? For which loading it will not valid? For which loading it will not valid? Anyone can tell me? For which type of loading this relationship cannot be valid? Anyone can tell? Anyone can tell? For which loading this relationship will not be valid? If I am saying if degree of loading is n, SFD n plus 1, BMD n plus 2. So is it valid everywhere? Definitely the question may come in your mind. So I am saying to you it's not valid at one particular loading. Other than that it's valid everywhere. So it's not applicable except uniformly distributed moment. Okay, if uniformly distributed moment is present, then this relationship will not be valid. Other than that, this relationship is valid all the time. Okay, in all the beam, you can apply this concept, it will be valid. Other than only uniformly distributed moment is present, then this will not be valid. Okay, yeah, very good Bhagyasri. This will not valid in the case of uniformly distributed moment. Other than that, it will be always applicable. So be careful. The UDM question have already come in the exam. If you see, the bending moment comes directly the 0. Okay, the bending moments come directly 0 and thus SFD comes rectangle in the that particular question. Okay, means if I take this question, a simply supported beam is subjected to uniformly distributed moment m kilonewton meter per meter. Okay, and length is L if I consider here. So if you draw the shear force diagram for particular this case, you will see shear force diagrams comes like that. Okay, shear force diagrams come like that and bending moment diagrams comes here perfectly nothing and bending moment is 0 on the complete beam. Okay, so I am talking about this particular case. Here you can see the shear force diagram is constant but bending moment diagram is 0. So here this concept will not be applicable. Okay, here this concept will not applicable. Other than that, this concept is applicable for all types of beam. Okay, so these are the points. Now I am writing 4 to 5 more points. With the help of that, you can solve all the problems related to the SFD BMD. Okay, just by 4 to 5 points. I hope so you have drawn in the college time, cut the section and to see either left or right. I don't want you to cut the section or anything. I just want you to see the loading. Just see the loading and draw the diagram. That only we have to do. More than that I don't want from you. Okay, just by seeing the loading. By seeing the loading, this table will help you a lot. If UDL is there, shear force diagram will be triangular, bending moment diagram will be parabolic. If UVL is there, shear force diagram will be parabolic, bending moment diagram will be cubic parabola. If point load is there, shear force will be rectangle and bending moment diagram will be 1 degree. It means it will be a triangular shape. Okay, so no need to just cut the section and all. By seeing these things, but just apply these concepts, your question will be over. Okay. So now what I am saying is, I am writing some point so that maybe help you for the drawing the SFD BMD. So what are those points? The first point is shear force is always constant between 2 point loads. Okay, 2 point loads are present and shear force diagram will be always constant between them. Point load means it can be the reactions also. Okay, point load means reaction is also a point load only, right? Reaction is also the point load only, right? So shear force diagram will be always constant between the point load. Like if I say a simply supported beam is there and point load P is applied at the center. When you draw the shear force diagram of this, how the shear force diagrams come? Shear force diagrams comes like that. P by 2, P by 2. Okay, shear force diagrams comes like that. So you can see here reactions comes P by 2 and also here comes P by 2. So in the between 2 point load, shear force is always constant. Here also you can see in between 2-point load, shear force is always constant. So be remember this. Second, at supports, total shear force, at supports, total shear force will be equals to support reaction, okay. At supports, total shear force will be equals to support reaction. You can see here support reaction is P by 2, so shear force also come P by 2 only, okay. Why I am saying total? You can see here total shear force is P by 2 and P by 2 P. So that's why I am saying it's the total shear force will be equals to the support reaction, okay. Third point, if shear force changes its sign, okay, if shear force changes its sign, then what will happen? If shear force changes its sign, then what will happen at that particular section? If shear force changes its sign at any section, then what will happen? Then if shear force changes the sign, then what will happen? Then always bending moment will be maximum at that section, okay. Bending moment will be maximum. The bending moment will be maximum. So whenever question is asking to you find the maximum bending moment, so what you have to see beta, you have to first check where the shear force changing the sign, okay. On those section only you check what is the bending moment, and in that what are the maximum value, that will be your final answer, okay. So whenever question asking to you maximum bending moment, just cut the section, just check those sections where the shear force have changed the sign, that will be your final answer, okay. If bending moment changes its sign at any section, then shear force will be, then shear force will be, anyone tell me? If bending moment changes its sign at any section, then what you will get? Here you got, if shear force changes its sign, we are saying the bending moment is maximum, okay. If bending moment changes its sign, then what you will say? If bending moment changes its sign, then what you will say? If bending moment changes its sign, remains same. If bending moment changes its sign at any section, Bhagyashree, it means you are not getting any information about shear force, okay. So you cannot comment on shear force. With the help of shear force you can comment on bending moment, but with the help of bending moment diagram you cannot comment on shear force. Very clear in the mind, okay. Then we cannot say anything about shear force, okay. This is very important. The question may come very soon in the exam. If shear force changing its sign if bending moment changing its sign, you will not comment about anything about the shear force, okay. Only when the bending moment changes its sign, the point is called as point of contraflexure, okay. The point is called as point of contraflexure, where the bending moment changes its sign, where bending moment changes its sign. So that point is called as point of contraflexure, okay. The point is called a point of contraflexure. Now you can ask me, sir, where it will be useful, point of contraflexure? This point of contraflexure helps us to draw the deflected shape of the beam, okay. In the deflected shape, wherever the curvature will change, that point will be point of contraflexure only, but in the deflected shape we use the different word, that's the point of inflection, okay. Where the curvature change, in a deflected shape, the point is known as point of inflection. Okay, but how you will get the point of inflection? With the help of point of contraflexure only. Point of contraflexure means where the bending moment changing its sign, not bending moment is zero. Okay, not bending moment is zero. Bending moment changing its sign, then only it's a point of contraflexure. Don't remember it's a bending moment is zero, because if you draw the simply supported case bending moment diagram, it comes like that, PL by 4. If you say bending moment is 0, here you will say the 2 point of contraflexure are here 1 and 2. No beta, point of contraflexure is defined when the bending moment changes its sign. Okay, it can be positive to negative, negative to positive, doesn't matter. Okay, it can be positive to negative, negative to positive, doesn't matter. But this is very important. This is very important. It will be only sign change from positive to negative. Okay. All right. One more last point here. One more last point here. What is the last point? Let me draw one bending moment diagram. A simply supported beam, let us say, subjected to moment M. Okay. If you draw the bending moment diagram for this case, you get bending moment diagrams like that. Here it will be M by 2, M by 2. Okay. Why this is important? This concept is very much important while you are drawing the loading diagram with the help of bending moment diagram. This concept have been used in 2006. Okay. On this concept, the question have come in a gate 2006. Why 2006? Again, you know, IIT Kharagpur. That's why this concept is very much important for you. Okay. You can see what the concept here. If bending moment is suddenly changing, if bending moment is suddenly changing, it means couple is present there. Okay. If bending moment ordinate is suddenly changing, you can see up to here it's there and it changed to again that. Okay. So in this case, if bending moment suddenly change, it can be positive to negative, negative to positive, but definitely there couple will present. Definitely there couple will present. It means some external movement is present. In a bending moment diagram, if you are seeing the sudden change, it can be sudden increase, sudden decrease. Definitely couple is present. That's why this concept is very much important. Okay, that's why this concept is very much important. Like if I gave you this question and if I ask you draw the bending moment diagram, sorry, loading diagram, I have given you this bending moment diagram. I am asking to you draw the loading diagram. How you will draw? How you will draw? You can see the bending moment is suddenly changing. Here it's a minus m by 2, here it's a plus m by 2. So m2 minus m1. So plus m by 2 minus m by 2. Okay, and it will be our plus m by 2 m, and this is positive. Positive means our movement will be clockwise. We consider clockwise movement positive, anti-clockwise negative. So this will be our positive movement. Okay, so always you have to follow this thing. You have to see where it's going here to here. So this minus this, it will be our clockwise movement. Okay. So this is the concept of shear force diagram and bending moment diagram. With the help of these 6 to 7 slides which I have covered, you can draw the shear force diagram or bending moment diagram for all the questions. Okay, whatever questions are there, you these 5 to 6 concepts, you will get the answer. Okay, you will get the answer by using these concepts only. Okay guys, so let's solve some questions now. If you have any doubt, you can ask me. If anyone any doubt, you can ask me. Anyone any doubt, anything from your side? Anyone any doubt? All right, just solve some questions. Answer fast. Answer fast. All of you solve fast. All of you solve fast. what question is saying? The question is saying, for a loaded cantilever beam of uniform cross section, the bending moment in Newton mm along the length is given to you this 5x square plus 10x, where x is the distance in mm measured from the free end of the beam. The magnitude of shear force at x is equals to 10 mm h. Without using the pen, you can tell the answer. Like I told you before starting the class, you can solve the question without using the pen of this chapter. Okay, and you have to solve. In the very rare questions, you need to use the pen. Okay, so you can see here what is given to you. Mx is given to you. Very good, Mayank. 5x square plus 10x. What question is asking to you? Question is asking to you shear force at 10 mm. Shear force at 10 mm. So you know what? What do you know? You know the relationship between shear force and bending moment diagram. You know the relationship between shear force and bending moment diagram. What the relationship? You know what? V is equals to dm by dx. V is equals to dm by dx. So if m equation is given to you, if you do the first derivative of this, so what you will get? 10x plus 10. If you do the first derivative of this equation, you will get 10x plus 10. So shear force at x is equals to 10 mm. So put 10 into 10 plus 10. How much it will come? 10 times 100. 100 plus 10, it will be 110, and it's in a Newton. The equation is also in the Newton. 110 will be the answer. Okay, 110 will be the answer. So you can see the questions are really very easy from this chapter. Okay, the questions are really very easy from this chapter. So no, we should not miss any single marks from this chapter. If the question comes, हवा में उड़ जाना चाहिए क्वेश्चन देखते ही. ओके, क्वेश्चन को हवा में उड़ा देना है बिल्कुल से देखते ही, कि मतलब 3 से 4 कॉन्सेप्ट है, दिमाग में घुसा लो, सारे क्वेश्चन हो जाएंगे उससे खाली, है ना. तो कुछ दिमाग ज्यादा लगाना नहीं है. यहाँ पे फ्री के नंबर है, ये नहीं छोड़ने हैं यार. ठीक है, फ्री के नंबर बिल्कुल नहीं छोड़ने हैं. आओ नेक्स्ट क्वेश्चन पे. कम टू द नेक्स्ट क्वेश्चन. All of you try. All of you try. Answer. Which option is correct? Which option is correct? Which option is correct? Anyone? Okay, Bhagyasri, very good. So you can see here, again the same logic I told you. The bending moment diagram for a beam is given below. This is the bending moment diagram given to you. Okay, the shear force at section AA dash and BB dash respectively are of the magnitude. So question is asking to you, at section AA dash, this is my section AA dash, and this is my section BB dash, what will be the shear force and what will be the bending moment, what will be the shear force here. So you can see bending moment is given to you and question is asking to you shear force. Again you know the relationship, very good Mayank. V is equals to dm by dx. तो भाई जरा सा दिमाग लगाओ, जहां सेक्शन AA dash है, wherever the section AA dash is, the bending moment is constant. you can see bending moment is constant. Bending moment is constant means bending moment is 100. It's a constant of 100. So if you see bending moment will be constant, if you do the first derivative of any constant, what will be the shear force? If you do the first derivative of anything constant, what will you get? If you are doing the first derivative of any constant, if I ask you d by dx of 2, okay, any quantity, what you will get here? If I do the first derivative of 2 with respect to what you will get? You will get here 0. Similarly, you can see here, if shear bending moment is constant in particular section, definitely shear force will be 0. So you can see here option B and C is there, A and D is not into a picture. Only B and C is into a picture because both are 0. Now come to the BB dash. You can see here BB dash is here, and in that region the bending moment is varying linearly. If the bending moment is linear, what will be the shear force? What will be the shear force in this section particularly? If bending moment is linear, what will be the shear force? Remember this table. See this table. If bending moment is linear means 1 degree. If bending moment is 1 degree, shear force will be constant here. Shear force will be constant here, yes or no? So you can see in this problem, if bending moment is linear, so we can say definitely shear force in that particular section will be constant. Okay, now how to find shear force? You know what? Same relationship, V is equals to dm by dx. For dm by dx, what do you need? You need moment at 2 points, moment at any 2 points. So you know bending moment here, bending moment here. So I can say here 200 minus 100 because dm means m2 minus m1. So you can apply this equation in between anywhere two section. You can apply this equation because you know shear force is going to be constant here. So m2 minus m1 upon, what is the distance between them? Distance between them is 2 minus 0. How much it will come? 200 minus 100, 100 by 2, it will be 50 kilonewton. So what will the answer? Option C is correct, beta. Option C is correct. Why I am writing like that? Because it's the dm by dx. Dm by dx means it's a m2 minus m1 upon x2 minus x1. Okay, we needed two sections where bending moment is known to us and distance is known to us. You can see here bending moment is 100, here 200, that is known to you. So m2 minus m1 upon x2 minus x1. Here distance, let us say 0 and this is 2. So 2 minus 0, it will be a 50. Okay. So always if question is dealing with shear force bending moment diagram relationship, first think about this relationship. 100% your question will be over by using this relationship only. You should not go anywhere else. Anything should not come in your mind. Only these two relationships will over your question, beta. Okay. So no need to fear. Completely these two things you have to remember only. Okay. Alright. Any doubt? Any doubt? Any doubt? Any doubt here? Shall I go ahead? Next question. All of you try this problem now. This is the favorite question, okay? This is the favorite question if you talk about the last 20-30 years. Which question the best question from the shear force diagram, bending moment diagram? This is the best question, okay? I hope so. Maybe all of you remember the answer also of this question. What will the answer? But still, this question is very good, okay? The concept must be clear. Nowadays, the questions are coming in the exam, so they are playing with the fluid mechanics plus strength of material, okay? So they are playing with water plus structures. So that's why these types of questions become very much important. Okay, I hope so all of you know the answer of this question. I hope so all of you know what the answer of this question. Okay. So the bending moment diagram, I hope so all of you know. Let's solve this question. If you don't know, then I will solve the question. It will not take much time. The two pupils weighing W each are sitting on a plank of length L floating on water at L by 4 from the either end. Neglecting the self weight of the plank, very good Mayank, the bending moment diagram at the center of the plank is. So what is happening? There's some wooden plank is there, okay. There's some plank. In that two pupils of weight W. Two pupils of weight W is sitting at L by 4 distance. Total length is L. Two pupils of weight W is sitting L by 4 distance from either end. And this block is floating on a water. This block is floating on a water. Here its water is there. Here it's completely water is there. So question is asking to you, what is the bending moment at center? Question is asking to you, what is the bending moment at center? Okay, this is the question. Now one common sense is saying to me, if wooden plank is floating on the water, so definitely the water will apply some upward force on that. Okay, the water will apply, and you can see the water will be same everywhere. This and this, everywhere the water will be same. So this the water will be which type of loading? This water will create which type of loading? You can see which loading is this. If every point is subjected to same load, so this is which type of loading? This is which type of loading? This loading is called as our UDL. This is called as our UDL. It means the water will produce the force that will be UDL from the upward. Okay, the water will produce the force upward, that will be very good Atul, that will be upward. Okay, and water will produce the force upward only. The water will produce the force upward only, right? So that will be upward force. I am saying, let us suppose the intensity of this UDL is small w. Intensity of this UDL is small w. Okay, I am saying intensity of this UDL is small w. Am I audible? Am I audible? Am I audible? Anyone confirm? Alright, Atul. Yeah. So this UDL is there, and let us suppose the UDL intensity is W. Now you can see beta, when the block is floating on that, it means what? It means completely the plank is in equilibrium. Plank is in equilibrium, yes or no? If plank will not be in equilibrium, definitely it cannot float. If plank is not in equilibrium, it cannot float. So if you apply here sigma Fy is equals to 0. If you apply sigma Fy is equals to 0, so you can see this W is downward, this W is downward, so W plus W, and this force is upward, and W is intensity of this UDL, it is acting over whole length L, so it will be W into L, so small w value will come here 2W by L. The intensity of UDL will come 2W by L. Anyone any doubt? Anyone any doubt? The intensity will come 2W by L. Why? Because the block is in equilibrium, so two forces are downward and this WL is upward. So W plus W must be equals to the downward force must be equals to the upward force. So W plus W must be equals to the W into L, and intensity is this. Now my game is over. Now my game is over. What question is asking to me? Question is asking to me, find the bending moment at center. So I am saying bending moment at center. Anyone can tell me what should I write? Bending moment at center we have to find. What should I write? Anyone? The bending moment at center. What is bending moment? Bending moment is summation of moment either left or right. So wherever you want to see, you can see. Okay. So here the bending moment will produce by this W and this UDL. Okay. So first this W, if I ask you, what is the bending moment due to this W? W into this distance. So what is this distance? This is L by 4. This is L by 4. What will be this? Total length is L. L minus L by 4. L by 4. How much remains? L by 2. L by 2. So this distance will be half of L by 2. So this will be L by 4, yes or no? This length will be L by 4, yes or no? This will be L by 4 and this will be L by 4, yes or no? Yes or no? L by 4, L by 4, L by 4. So the bending moment due to this W will be W into L by 4. W into the bending moment will be W into L by 4, and you can see this will be like that. I am seeing left side, it will be hogging bending moment. It means this will be negative. It means this will be negative. And now due to this UDL, bending moment will be like that. It means it will be sagging. And what is the bending moment? W into what is this length? What is this length? This length is L by 2. So W into L, WL by 2 into what is the bending moment of this UDL? You know, right? Bending moment of UDL, generally you write WX square by 2. So I am writing same thing here. X is what here? L by 2. Okay, so WL by 2 into L by 4, or you can write here WX square by 2. Okay, so here it's a minus WL by 4. This is my W is UDL intensity. What is the value here? It's a 2W by L. 2W by L into L by 2 into L by 4. So you can see here 2 to 2 cancel. Okay, L to L cancel. It will come WL by 4 with the positive. It will come WL by 4 with the negative. Answer will come here 0. Okay, answer will come here 0. Okay, here answer will come 0. It means option D is correct. Many state exams, many exams have been asked this question directly. Okay, many exams have been asked this question directly. Answer is 0. But must understand the concept, beta. Must understand the concept how the things are happening. If the water is present, so I hope so all of you know the pressure due to the water is rho GH. Okay, so maybe rho GH concept also can be used sometime in the exam. So don't be fear. Okay, don't be fear. If somebody say on this beam height of 3 meter water is present. Okay, so what you will say? It means the pressure will be rho GH. This much height pressure will be applicable on the beam. Okay, so you have to be very smart while solving the problem related to the water plus strength of material. They will not go in much detail. They will just go with the very basic concept that will be a rho GH, the water pressure. Okay, and it's like that. If water is present, water will apply the force upward. That will be a UDL and answer will be 0 here. Anyone doubt? Anyone doubt? Anyone doubt here? Shall I go ahead? Bhagyasri, Jyoti, Gupta. Anyone doubt? Atul. Alright, next question. Answer, tell me fast of this question. Tell me answer fast. This dotted line is at center, beta. Okay, this dotted line is just the center of this. So don't be confused with this. Okay, this dotted line is the center of this. All of you solve fast. Answer, Atul, Mayank. A simply supported beam is there, but loading is not given to you on the beam. Loading is given with the help of one bracket here. Okay, the loading is given to you with the help of one bracket. So if I simplify the diagram, diagram will be like that. Diagram will be like that. Okay, you can see we can transfer this force on the beam. I hope so all of you know how to transfer the force on the beam, yes or no? We can transfer this force on the beam here only, means at the center we can transfer the force. How can you transfer the force? How can you transfer the force? You know, I hope so all of you know, right? What will we do? Apply 100 downward, apply 100 upward. So you can see these two forces are what? These are two equal opposite parallel forces. These two forces are equal opposite parallel. So I hope so all of you know, when two forces are equal opposite and parallel, then those forces create a couple. Okay, those forces form a couple. So these two forces will form a couple of magnitude what? You know how to calculate the magnitude of couple? Couple magnitude is force into distance between them. So what is the force? Force is 100. What is the distance between them? It's a 100 mm. So let's convert into the meter. So that will be 0.1. So that will be 10 Newton meter. Okay. So meaning this diagram can be converted like that. 100 Newton here and movement will be here 10 Newton meter. This length is 500 mm. So I am saying it's a 0.5 meter. And here I am also saying this is 0.5 meter. Okay. So this is the question. Question is asking to you, find the maximum bending moment. All of you tell the answer first. I just simplify the problem like that. If you see the force is not on the beam, you have to transfer the force on the beam first, then only you can move ahead with the problem. Other than that you cannot go ahead. Okay. So you must have to transfer the force first. All of you do it fast. $60. Why Atul? This is the maximum value looking like. Because this is the maximum value present in the options. All of you try fast. Atul, it's wrong. Just try again. It's wrong. Open the eyes. Okay. Open the eyes as well as the mind both at the same time. Mayank, check again. Check again. What is the maximum bending moment here? Try. Can I break this beam like that? Can I say this beam is like one point load is here at the center of 100 Newton and plus one couple is there of 10 Newton meter here? Yes or no? If I add these two beams, you will get this beam only. If I add these two beams, you will get this beam only. For this case, a simply supported beam subjected to point load. What is the maximum bending moment diagram? What is maximum bending moment? A simply supported beam subjected to point load. What is maximum bending moment? I hope so all of you know. That is PL by 4. What is P here? 100. What is L here? Length is 0.5 plus 0.5. L is, Pooja, just check once better again. So WL by 4, it will come 25. So 25 Newton meter is coming from this. Means if you draw the bending moment diagram for this particular case, the bending moment diagram comes like that. Here the value will coming. Here the value is coming 25. Just now I told you what is the bending moment diagram for this. Just now I told you what is the bending moment diagram for this. Bending moment diagram for this is like that. Yes or no? The bending moment diagram for this couple is, it's like that. Yes or no? Just now I told you. You can see here. Just now I told you, if couple is present, the bending moment diagram will be like that. Yes or no? If I told you, so some logic is there behind that. Okay. If I am telling you, some logic is there. The gate have been asked the question from this logic. Okay. So now one thing is here. What bending moment will come here? M by 2, M by 2. 10 is here. 10 is the total. M by 2 means 5 will go up, 5 will go down. So you can see what the total bending moment which is upward. 25 plus 5. Yes or no? What the total bending moment? 25 plus 5. That is positive bending moment diagram. Positive bending moment. What the negative? It's a only 5. Okay. So what the maximum bending moment here? What the maximum bending moment here? 25 from this, 5 from this. What the total bending moment diagram? Bending moment. The maximum bending moment is 30 beta. Okay, so this is the shortest way to solve this problem. Maybe you can say, sir, I will calculate the bending moment directly. You can calculate, not a problem. But if you know this thing without using the pen, you can tell the answer. Answer will be here 30. Okay, 25 is coming from this, 30 is coming from this. Either you can calculate the support reactions first. You can calculate the support reactions first, and you can calculate the bending moment, because loads are at center. So bending moment will be maximum at center only. Okay, because loads are at center. So bending moment will be maximum at center. You can calculate the bending moment at center. Okay, means if you draw the combined bending moment diagram for this, the bending moment diagrams will come like that. Okay, here it will be 25, here it will be 30. So bending moment diagram will come like that for this particular question if you will draw. Okay, so you can draw, not a problem. But if you know the standard results, with the help of standard results, you can solve the problems in a seconds. Okay, so that only we have to do in the exam. That only we have to do in the exam. Solve the questions in a second. How? By using the standard results only. Okay. Anyone doubt in this? Anyone doubt? Next question. All of you tell the answer fast. All of you try. Pooja, it's clear. Mayank, it's clear now. It's 30. How? Right? Last question. Atul. Okay, all of you try. I mean, these are the questions. By seeing, you can tell the answer. These are the free marks in the exam. Okay. This is completely free marks. J, it will not come, it's 10. You can calculate. What is the support reaction it's coming? What are the support reactions are coming? What are support reactions are coming? B. Okay. PL by 2. P by 2. Very good, Mayank. Yeah, Jay. What are the support reactions are coming here? No, support reactions you are calculating wrong, beta. Support reactions you are calculating wrong. Support reactions will come. Beta, you are considering only the effect of this force in a support reaction. Jay. Beta, moment is also present now. This 10 is also present. So consider the effect of this also while calculating the support reaction. You are taking only 100, so you are saying 50-50. No, bhai, couple is also present. Take the effect of couple also while calculating the support reaction. If you calculate support reaction, it will come 40 here and 60 here. Okay, support reaction will come 40 here and 60 here. Then you calculate, answer will come same. Okay, then you calculate, it will come same only. Okay, you can try. Yeah, this question. Yeah, man. Yeah, 40 and 60 will be support reaction. At one support it will be 40, other will be 60. This question, I told you when I start the class, internal hinge. Internal hinge, whenever you see, break the beam. Okay, whenever you see the internal hinge, break the beam. If you break the beam here, it means this is my beam like that. Okay, this is my beam like that. I am breaking the beam like that. Now one thing is, if this side support is there, so definitely from this side, 1 second. Yeah. Pooja, check once again, beta. You can see, I break the beam and here load P is there. Now by common sense I have to see. You can take anywhere, I am not saying, but you see beta, here P load is there. Here one reaction is there, one support is there, it means some reaction is here. Now, my common sense is saying to me, for maintaining the equilibrium of this beam, definitely support reaction should come upward only. Yes or no? Support reaction should come upward only, and this support reaction will transfer here in opposite direction. It means it will transfer downward. Here it will be upward, here it will be downward. Now, anyone any doubt? Now you can ask me, sir, can we take downward? You can take, bhai. Automatically, if you do the mathematics, it will come opposite. Okay, you can take, it will come opposite automatically. Okay, it's a R. Now can you tell me, this length is L, this length is L, what will the support reaction here? It will be P by 2, P by 2, yes or no? It will be P by 2, P by 2, yes or no? Yes or no? It will be P by 2, P by 2, P by 2, P by 2. It means this will be also here, sorry, this will be also here P by 2. This R will transfer in opposite direction. So this R will be here P by 2. Question is asking to you bending moment at A. It means question is asking to you bending moment at A. So P by 2 is the force. Length is here L. So what will be the bending moment? What will be the bending moment, Pooja? It will be 0. It will be 0 bending moment. It will be 0 bending moment. No beta, bending moment diagram will not be, bending moment will not be 0. It will be P by 2 into L. It will be PL by 2. Bhagyasri, you are saying yes for 0. It will be PL by 2. Okay, the bending moment diagram will be, bending moment will be at A. It will be P by 2 into L. It will be PL by 2. It will be PL by 2. Okay, it will be PL by 2. Anyone doubt? Anyone doubt for mechanical? These are the favorite questions. Okay, in the mechanical the questions comes very easy actually from this chapter. So this is the favorite question for the mechanical. Okay, anyone doubt? Shall I go ahead? The only thing is you have to break the beam at a hinge. You can take the support reaction anywhere, upward, downward, but once you are taking up, other it will be down. Once you are taking down, other will be up. It's completely your choice. Next question. Now tell the answer of this question without using the pen. Okay, without using the pen, tell the answer of this question. Without using the pen, tell the answer of this question fast. Without using the pen, beta. Okay, see the question, answer. Very good, Mayank. Bhai, again hinge is there, so I will break like that. I will break like that. Means here one reaction will be upward, one will be downward. 10 is there in the center. It means it will be 5 here. Okay, 5 is here. 5 will go here. So 5 into 2, it will be 10. It will be 10. It means option C is correct. Okay, it means, very good Bhagyasri. It means option C is correct, beta. Okay, so like that you can see the same types of problems are coming continuously here. Okay, same types of problems are coming. That's why I always say the gate doesn't have a new problems now, beta. The gate doesn't have a new questions to ask. They will ask you the questions whatever they have asked before. Only the diagrams will change. Only the diagrams will change. The concept is not at all going to change. Okay, today I am saying after the gate exam, I will say again same thing. I will prove you that those types of questions they have asked already in the exam. Okay, so be cool. Just follow the previous year questions again and again. Whenever you are free, just open the book of gate previous year question and solve it. Okay. Next question. All of you try. All of you try. Answer again. I am saying without using the pen. Okay. Very good, Mayank. All of you do fast. Guru Prasant, to the question. Answer, everyone. No, Ram Prasad, it's wrong. I told you what we have to do. Wherever you see the hinge, break the beam. Okay, wherever you see, break the beam. So here you can see hinge is there and roller. Now the doubt will come in your mind, sir, 10 kilonewton is also apply on hinge. Where it will go? It will go left side or right side? Yes or no? Definitely the question will come in your mind. Okay, definitely the question will come in your mind, where this 10 will go? On this beam, because here hinge is there, hinge I will break, so I am putting here R and one R here. Okay, remove the hinge, break the beam. Now the question will come in your mind, where the 10 will go? Wherever you want, you can take beta. You want to take left side or right side, it's completely your choice. I can show you by both way. Let's consider this is on right side, let us say 10 is here. If 10 is here, question is asking to you reaction at Q. Let us say this is P point beta. So this is reaction at P and reaction at Q. Just calculate all of you reaction at Q, how much it will come. I am considering this 10 is on right side. How much it will come? Tell me. How much it will come? Reaction at Q. Take the moment about P. If you say sigma MP is equals to 0, so you can see RQ will become automatically 0 here. RQ will become 0 here, yes or no? Yes or no? RQ will be 0, it means answer is 0. Now the question may come in your mind, sir, why are you taking right side? I want to take left side. Oh bhai, take left side. I am saying let me take left side. Okay, this is my beam. This is my reaction at Q. This is my reaction at P. And this is my reaction at P. And also you are saying that 10 is also here. You are saying 10 is also here. Now just see this side beta. This is reaction at P, reaction at Q. Is there any force is there on this beam? Is there any force is there on this beam? Is there any force is there on this beam? There is no force on this beam. Definitely both reactions will be 0. Definitely both reactions will be 0. So what question is asking to you here? Reaction at Q. Reaction at Q will be how much beta? Reaction at Q will be how much here? There is no loading, so definitely RQ will be 0 from here also. So you can take either left or right, it's completely your choice. Answer is not going to change beta. You can take left or 10 left side also, right side also, answer will be same in the last. Okay, so that's why I took this problem. Most of the times you get confused where the 10 will go, left or right, it's completely your choice. Our sign convention, our mathematics will take care about this, no need to worry. Okay, so next question. Continuously the problems are coming of this type, okay, in the exam. Continuously the problems are coming of this type in the exam. Try this problem now. All of you try this problem now. Answer. Answer. Very good. By seeing the question, you can tell the answer here, beta, again. Okay, you can see here, this is my beam, hinge is there, and this is my roller support, and it is subjected to UDL. Now, remove the hinge, apply the reaction R, here upward, here downward, here some force is there 50. Okay, what is the intensity of UDL given to you? 10 kilonewton per meter. What question is asking to you? Question is asking to here reaction at C. This is my reaction at B. Okay, So 10, length is how much? Length is here 4 meter. So what is the reaction at C? What is the reaction at C? 10 4 is 40, 40 by 2, 20. It means 20 kilonewton will be the answer. It means 20 kilonewton will be the answer of this question. Okay, so I hope you are perfect now in internal hinge problems, right? So wherever you see the hinge, break the beam. Most of the students go afraid while seeing the hinge in the problems. Okay, that's why I'm taking the hinge problem this much. No, there should not be any single doubt related to the hinge. Okay, very good Pooja, very good Ram Prasad. Okay, next question. Options are given to you, just a second. Tell the answer first. Answer. Do it fast. What question is saying? Some bending moment diagram is given to you. Question is asking to you, apply the, tell what is the loading condition possible on the beam. Very good Mayank. Do it fast everyone. Everyone do it fast. Jay, okay, very good. Very good. All of you I think got the concept. That's why I showed you this diagram beta. Okay. Always when this type of questions are there now, this diagram must keep in your mind beta. This bending moment diagram must keep in your mind. When bending moment is suddenly changing, definitely couple is present beta. Whenever you are seeing sudden change in a bending moment diagram, it means couple is present there. Okay, so now if you see this question, you can see this question. What is happening in this question beta? In this question if you see, here the bending moment diagram is came like that but suddenly changed. It means how much bending moment is here? 0. Here how much? M. So like M2 minus M1. So it will be 0 minus M because downward will be negative. So it will be M. So couple of M at C. You can see here it's a M. Is here also it's a M. So M2 minus M1. M minus of M. How much it will be? It will be 2M. So whenever the bending moment is suddenly changing, definitely their couple is present. So you can see at C it's a M, at D it's a 2M. So option A is correct beta. Option A is correct. That's the very good, very important concept. If somebody want you to ask the question, convert bending moment to loading diagram, definitely they will use this concept beta. Definitely they will use this concept where the bending moment is changing suddenly, couple is present. You must have to remember. Okay. Last question. Jay beta, if I show you here, is any load is there in between this and this point? Is any load is there in between this and this point? Is there any load in between this and this point? No. Okay, it's not like that. If bending moment suddenly changing, it means definitely couple is present. That is happening due to couple. Okay. Because here if you calculate the support reaction, here the support reactions will come here M by L, M by L. Okay, if you calculate the support reactions here, M by L, M by L. So these straight lines, these lines are coming due to this M by L and this M by L, because support reactions are there. That's why it's not coming completely like this. This line is coming because support is there. Due to support, some reaction is there. Due to M by L, M by L, this is coming. Okay, clear? Solve this question now. JX, clear? Question is asking to you now in this now. For the overhanging beam shown in the figure, the magnitude of maximum bending moment is. I told you beta, whenever the question asks you find the maximum bending moment, it means first you have to find where the shear force changing its sign beta. First you have to find where the shear force changing its sign. Okay, and it's a overhanging beam, so we don't know the standard result also, right? So first what we have to do, we have to draw the shear force diagram. Now how I draw shear force, just see. Can you tell me the support reactions, how much it's coming? RA and RB. Overhanging beam is there, you must have to calculate support reaction. Can you tell me how much support reactions are coming? RA and RB. First, how much support reactions are coming? How much support reaction is coming? Anyone can tell? First, RA 10, okay. RB 50, 40 plus 20, 60, 10 or 50. Anyone confirm? Anyone confirm? RA, RB how much? RA 10, RB 50. RA 10, RB 50. Anyone confirm fast? How much it's coming reaction? Support reactions, RA, RB. How much fast? Correct. 10 or 50. Answer is okay. I'll come to that. So RB is coming here 50. RA is coming here 10. RA is coming 10. RB is coming 50. Now if I draw the shear force diagram, my beam is this. My beam is this 20. Okay, and reaction is here 10 and here reaction is 50. You know one thing beta, at support, Pooja check the calculation, it's wrong. Okay, at support, shear force is equals to support reaction, I told you already. So here it will be 10, so it will go 10. Now do you remember the sign convention of shear force diagram? This is my positive shear force and this is my negative shear force. So you can see right side force is downward, so right side downward force is positive. Okay, right side downward force is positive. So 20 will come how? How the shear force will come here? It will come constant, yes or no? It will come constant up to this point. Up to this it will come constant, yes or no? Now here reaction is how much? 50. So 20 is here. How much remains? Total shear force will be how much at support? Equals to support reaction. So 20 is here. How much remains? It will be 30, because total is 50. So 20 plus 30, it will be 50. Right? And here it will be 10. Now what you will do? UDL is there. You know, if UDL is there, shear force diagrams comes triangular. It will comes like that. So now you can see here shear force changing the sign at two places. One is this and one is this. This I know, this distance I know, this distance is how much? 2 meter, which is known to me. By similar triangle, can you find this distance? By similar triangle, can you find this distance? How much it will be? I don't know, right? I am saying this distance is x, let us say, but total is 4, so this will be 4 minus x, this will be 4 minus x. So can you calculate what is x value here? Can you calculate what is x value here? Everyone clear? SFD beta. Shear force is constant between 2 point load. 1 point load, shear force is constant. UDL is there, shear force will be linear. It's a linear. Okay. Now if I say this distance is x, this is 4 minus x, can you tell me what x will come? So by similar triangle you can say 10 upon x is equals to 30 upon 4 minus x. So x you will get here, x will be 1 meter. X will be here 1 meter. So what you have to do beta? You have to calculate bending moment at 1 meter. Let us say this point I am saying, this point is, let us say, D point. This point is D point, and last this point is E point, and this is my B point question I have given you. So you can see at B and D point the bending moment changing its sign. It means you have to calculate bending moment at 1 meter and bending moment at 4 meter beta. 4 meter means here at B point you have to calculate bending moment, means moment at B you have to calculate and moment at D you have to calculate. Okay. So how to calculate bending moment? Bending moment is summation of moment either left or right. So what is the bending moment at B? How much? It's a 20. This length is how much? 2 meter. So what is the bending moment at B? 20 into 2, it will be 20 into 2, it will be 40 kilonewton meter. Bending moment at B will be 40 kilonewton per meter. Very good Pooja, very good Bhagyasri. It will be 40 kilonewton meter. Similarly, can you tell me how much bending moment is coming at D? Bending moment D means it's a somewhere here beta. D point is somewhere here. D point is somewhere here and this distance is 1 meter. Okay, UDL intensity is given to you 10 kilonewton per meter. So can you tell me what bending moment is coming at D? What is the value of bending moment at D? Anyone can tell? So 10 into 1, 10 into 1, this 10 into 1, it will be sagging, so positive, and it will be Wx square by 2. So 10 into 1 square by 2 with the negative sign. How much it will come? 10 minus 10 by 2, it will come 5 kilonewton meter. So what is the maximum out of that? What is the maximum out of that? 40 or 5? 40 is maximum. So answer will be here 40 kilonewton meter. Answer will be here 40 kilonewton meter. Meaning is this beta, if question is asking to you find the maximum bending moment, first check shear force diagram. Where the shear force changing its sign, there the bending moment will be maximum. Okay, there the bending moment will be maximum. So you can see here this point and this point, the critical point. So I calculated the bending moment at both the places. Bending moment at D, bending moment at B, it will be 40 and it will be 5 kilonewton meter. So what is the maximum out of this? 40 is maximum. So 40 will be the final answer of this question beta. Okay. So this is completely all about the shear force diagram and the bending moment diagram. So tomorrow we will discuss about the bending stress and shear stresses. Okay. Yeah, very good Bhagyasri. So tomorrow we will discuss about the bending stress and the shear stress. Okay. And tomorrow we will complete both the stresses, bending and shear stresses. Right. And again I am saying, if you have specific any topic, if you want me to complete, I will complete that. Okay, just post in a chat box which topic you want. I will focus more on that. If you have a doubt in any specific topic, I will take that also. Okay, so if you have anything, you can ask me in the chat box. I will definitely clear your query. Okay, so this is for the today's class. We are done with the shear force diagram and the bending moment diagram. If any doubt is there related to that, you can ask me in the tomorrow class also. So again, tomorrow we'll meet at 6 p.m. Okay, alright guys, thank you. See you tomorrow at 6 p.m. again. Thank you.